Hi everyone, in this demo analysis I will show you how to use the listentodata R package to do a segmentation and targeting analysis. I will start from the very beginning, setting up RStudio and installing the listentodata package. If you go to modules on Canvas and go to week 2, under item number 3, you will find a little piece of code, 2 lines of code actually. These 2 lines of code install 2 packages for us. One is DevTools, the other is listentodata, the main course package. We need to install listentodata, but in order to install that, we need to install DevTools. So we have to install both packages. First, I'm going to go to Tools, Global Options, Appearance, to change my font size to 8 so my text looks a little bit smaller on this screen. Okay, here you have to create a new R script. There are 2 ways to do this. This is one way. Clicking that green circle with the plus and selecting R script, that's the second way of doing it. I'm going to paste the 2 lines of code that I copied from the modules section, resizing the windows a little bit here, and running that first line. You could put your text cursor anywhere on that line, doesn't matter. And in my case, DevTools is installed, so nothing happens there. But I have to install the second package, which is listentodata. And that's line 2. So I run line 2 as well and install the package. Okay, now that the packages are installed, they will remain on your computer until you remove RStudio and R. To test if your package was successfully installed, just type library listentodata in parentheses and you'll get a welcome message. So everything is set up for the course. You only need your codes to run the analysis. And to get those codes, first you can use the get underscore codes command and run it in the console. It first clears this console and then puts all the code there. So you can select all of the code at once and copy and paste it into your editor. So all the code is here. I call it Analysis Hub because it's where everything happens. You can save it on a safe place on your computer where you can always know where it is and access it as needed. Okay, now I'm closing RStudio. So this message that you get for saving the workspace, you don't need to save the workspace at all. Workspace consists of all the variables you have loaded into the memory, and you don't need to have that saved. And you can see I have my analysis hub here. Just at the end of the file, I have to go back up. Each analysis can be found in its own section. There are some help and practice sections at the top. But our first topic is segmentation and targeting, and that's where we will do our first analysis. Now, the listentodata package is already installed on your computer, but each time you want to use it, you need to call it to load it into the memory. And that's done with the library command, which loads packages. Library listentodata loads that package for us. The clear console function basically clears the console. Those load CSV data commands load a CSV data file and put it into the variable, in this case segmentation data. When you run this line, a file selection dialog is supposed to open, but sometimes, especially in Windows, it hides behind other windows. So pay attention to the taskbar at the bottom and that blinking icon there. That's your file selection dialog, trying to get your attention. For the demo, we have unzipped the demo segmentation zip file for Windows users. For Mac users, it's unzipped automatically for you. You don't have to have an unzip folder. The PDF is from a previous analysis, so I'm deleting that file. Okay, I selected the segmentation data file. It's loaded. If you check the environments, you can see that now we have a new object called segmentation data. If you click that play button there, you'll see the list of variables in it with some details about the variables. And if you click the name of the dataset, that text part, you will get. We have 434 observations here, which means 434 rows or 434 people whose data we have collected. Now I'm going to run the second line, load the targeting data. Same thing goes for the targeting data. You can check it out. You have to know what these variables are, and we talk about these in the classroom. The next line, you decide the number of segments, but this is not an actual final decision. This is for us just to run the code and see the script plot. Then we will decide what the actual number should be. Okay, I see an error here. Figure margins too large means the figure is too large for your space. That means that our space is small. So I have to resize this lower right panel where the pots section is, and this error will disappear. Running it again, it works, and we have the results saved. It's been saved in the same folder as your data files. On Windows, this is how you can get to that path through the Windows R or run command. First, you see a visualization of the hierarchical clustering process. Then you see the script plot. And we talked about how we read this script plot. We're looking for an elbow, a jump in information loss. You can see the overlap among the 3 segments we have selected. We always want to go with fewer segments, and if the information loss is kind of negligible between 2 solutions, like 2 segments versus 3 or 3 versus 4, we decide to go with the lower one. For this demo, 2 segments is the best answer because we see a huge jump in information loss if we go from 2 segments to 1 segment. So we don't want to go from 2 segments to 1 segment. We want to stay at 2 segments. And that's better than 3 segments because 3 segments is more work and not much more information. Now you can see how nicely separated the 2 segments are with little overlap. The next table shows us the segment sizes, which matter because if you have too many segments and some of them have small sizes, well, that's a sign you have selected too many segments to keep. This bar chart shows you a comparison between your segments and the population. We have accepted that there are two segments in this data set, two groups of people. It's time to understand who they are, what they care about. Now, this bar chart, you can see it also shows you the cluster sizes, cluster and segment. Each row is one of your segmentation variables. The bars show the average value of that segmentation variable for that segment that you're looking at. The dots, all at 0, represent the population mean. The population mean used to be non-zero, but we have standardized it. Comparing the bars with the dots, you can see some bars are higher than the dots, some are lower. If a bar is larger, further to the right than the population mean, which is the dot, that means people in that segment care more about that variable than the average population. Just take, for example, the first variable here, the importance of low weight. You can see that segment 2 answered this question, the importance of low weight, with higher values, which means they care more about it than the average population. In segment 1, they gave lower values to the importance of this variable. So the importance of low weight is much less than the population, and obviously much less than segment 2 for segment 1. That's how we read all these variables, and we have to know the definition of each variable. Make sure we understand what the name of that variable implies. You need a data dictionary for that, or you need to know the questions that were asked on the survey. So in this case, they have been clearly defined, so the names are self-explanatory. The next table shows you the same information, only in tabular format. So it's just the actual values of those variables for the population, which is the entire pool of your subjects who took this survey, the 434 people here, segment 1 and segment 2. We also calculate the difference of means between the segments and the population in the last two columns. Since we have two segments here, we have two differences. One between segment 1 and the population, the other between segment 2 and the population. With more segments, you would have more columns. Notice sometimes you see a positive change there, or positive difference, sometimes a negative difference, and sometimes you see 3 dashes. So when you see 3 dashes, that means although you are seeing some slight difference in the averages, there is no statistical difference. The differences that you see, the minor differences, are just random differences. So whenever you see those 3 dashes, you can say there's no difference on this variable. So in this case, in terms of Facebook usage, there's no difference between the segments and the population. Everybody is behaving similarly in terms of Facebook usage. But in terms of WhatsApp usage, you can see the difference. One segment is using more than the population, the other is using less. These are used for targeting purposes. So if you want to reach out and target segment 1, WhatsApp would be a better tool.